Formulas for projectile motion. So there's two different formulas. X answers the question, how far? This is a horizontal distance. Horizontal distance. So if you're asked how far, that is what you're going to use. That answers that question. How far? In order to write your equation, you are substituting in two numbers, v sub 0 and theta. V sub 0, does anybody know what that represents from physics? Velocity. V sub 0 is velocity. In every question, you will know your velocity or speed. That's what that V sub O represents. Okay? Now, Y doesn't talk about horizontal distance. It talks about vertical distance. Which answers the question, how high? That's the question it's answering. So either way, we're going to start by finding T. And depending upon if I'm looking for how far, I'm going to plug that into X. But if I'm looking for how high, I plug it into Y. Okay, let's look at our Y parameter. So Y has a couple of variables. First of all, you have G. G, we're only going to use one of these two. Okay, if the unit is meters, 9.81. But if it's in feet, 32.2. And we take that gravity and we multiply it by negative 0.5. And then we put that same velocity and we use the sine, because remember, sine is y, cosine is x. And h sub 0 is the initial height. Which for most of these, the initial height is 0 because the ball or whatever is coming from the ground. Alrighty. So it says a ball is kicked with an initial velocity of 60 and an angle of 38. So I'm going to go ahead and plug it in. So my x parameter, x of t, is going to equal initial velocity, which is 60, times the cosine of 38t. This is one number, by the way. Everything is multiplied. For your y parameter, so velocity is in feet. Does everybody see that? So we're using 32.2. And I want you to notice how it starts by multiplying it by negative 0.5. So what I want you to do is take 32.2 and multiply it by negative 0.5 to kind of simplify it down. Because whatever we use for gravity, we start by multiplying that by negative 0.5.
What did you say you wanted to multiply?
So G, your gravity. And because it's in feet, we're using 32.2. So 32.2 multiplied by negative 0.5 is negative 16t squared. And then it's plus 60 sine 38t. And my initial height is 0. Those are my two equations. And no, you don't have to put the plus 0 at the end. So B says, find the time in which the ball will return to the ground. Well, that tells me, I don't know how far away the ball is, but if something is on the ground, what's the height? 0. So I know that I need to start by using my height parameter to find time. So I'm going to take my y parameter, I'm going to set it equal to 0. So we have 0 equals, oh, it's supposed to be negative 16.1, y'all. Hold on. Negative 16.1 t squared. There we go. So we got negative 16.1 t squared plus 60 sine 38 t. We have to solve that for t. The easiest way to do that is to take out the GCF. And what is the GCF? T. Let's take out a t. When I take out a t, I am left with negative 16.1 t plus 60 sine 38. So I want you to notice that t appears in 2 places. The reason why is because the ball is going to be on the ground twice. All right? It's on the ground when it's kicked. So this is when it's kicked. And then it is on the ground when it lands. So there's 2 times that the ball is on the ground. So let's figure out our 2 times. This first one, t equals 0. This represents the initial. This is when it was kicked. It shouldn't be. I'm glad. Hey, listen, I only need one person. Just one person to pay attention. And I got my one. I appreciate you. There we go. Should not be a t at the end because we took it off. So now let's take this, set this equal to 0, and solve it for t. And I know that looks kind of crazy, but it's not that bad. So we have 0 equals negative 16.1 t plus 60 sine 38. First step I'm going to do is subtract. So I'm going to subtract the 60, which will be negative 60 sine 38 equals negative 16.1 t. And then when I divide, what am I dividing both sides by to solve for t? Good. So t is negative 60 sine 38 divided by negative 16.1. So it's on the ball at t equals 0. It's on the ground. The height is 0 when it's on the ground. The height is 0 when it lands. So type that in your calculator. Negative 60 sine 38 divided by negative 16.1. And you should get that it takes 2.294 seconds. Because it's asking us, find the time it's going to return to the ground. So this is my answer to part A. Okay, so again, we have our ball. We kick the ball. It comes back to the ground. We need to know now in part C how far it traveled. What parameter answers the question how far, x or y? X. So I'm going to use my x parameter. 60 cosine 38 and multiply that by 2.294. Type that in your calculator. And that's going to tell me the distance that it traveled. What did you say? Yeah, so what I would do is close the parentheses after the 38 and then start a new parentheses. So you should get 108 2.462 feet. That is the horizontal distance. So we're looking at the motion of the ball. This is t = 0. It returns at 2.294. And the distance it traveled is about 108. Yes. You didn't get that. Is it in degree? So that's a decimal. It's 2.294.
Oh.
Yeah. 2.294. All righty, let's look at number 2. So during a football game, Delmar attempts a 45-yard or 135-foot field goal. He kicks the ball at an angle of 41. So that's my theta, with an initial velocity of 54 miles per hour. But we don't have a gravity that measures in miles. Remember, we only have meters and feet. So we're going to use 79.2 feet per second. We also know that the goal is 15 feet high. So that helps. So let's go ahead. Oh, we also know that his horizontal distance is 135. So let's go ahead and make our equation. So we got x of t. We're going to substitute in his velocity, which is 79.2, cosine of the angle, which is 41t. We're in feet, so we're using 32.2. If you divide that by, or multiply that by negative 0.5, you get negative 16.1 t squared plus 79.2 sine 41t. And we're going to assume that the kick is from the ground. All right. And he's kicking it is from the ground. So again, my initial height is 0. So we need to know how long it will take for it to reach the pole. And we need to know how high the ball is when it reaches the goal. So we don't know, we don't want to know when it hits the ground again. All right, so I can't use my vertical one because I don't care when it hits the ground. I want to know how high it is when it hits the goal. So do we know how far away he is? How many feet is he from the goal? So we have our horizontal distance, so we can use our x parameter. So I want you to substitute in 135 right here. This is a number. This whole thing goes together. So you're dividing both sides by 79.2 cosine 41. So in your calculator, you're typing in 135 divided by 79.2 cosine 41. That's just going to tell me how long it's going to take for it to reach the goal. So what is the time that it will take for the ball to reach the field goal? All right, so we got 2.259 seconds. That's how long it's going to take to reach the post. Time to reach post. Now I want to know what the height was when it got to the post. So which parameter will tell me height? Y. Let's go ahead and take that number. You okay over there, Miss Anaya? We got to lock in. We need to put that phone up, sis. Can't do two things at one time. Which one you doing? So we got Y equals, and we got negative 16.1 parentheses squared plus, oh wait, hold on, I need some more space. Okay. plus 79.2 sine 41 parentheses. So I want you to take that t value that we got and substitute it in your vertical parameter. So we got 35, who got 35.218 feet? So in football, is that high enough to clear the goal? How high is the goal? How many feet is the goal? 15. So we want it to go over, right? So is the 35 over? So the answer would be yes. Yes, because the height, and you don't have to write this explanation, is higher than the post. Three more for today. And actually we'll be done. We're not doing the last question. 3 more. Okay, so now we switch into soccer. So Beth kicks a soccer ball straight towards the goal that was open. The goal is 60 feet away and 5 feet high. So we know how far away Beth is from the goal. We know the horizontal distance. That's important. The velocity of her kick is 50 feet, circle feet, per second, and the angle is 30. Now, soccer, I'm assuming when you kick a ball in soccer, it's on the ground. So we're going to assume the initial height again is 0. So let's write our equation. Our x parameter, our velocity, 50, cosine, the angle, which is 30, t. That's my x parameter. Your y parameter, because we're in feet, I'm using 32.2 again. Multiply that by negative 0.5. So I'm going to start my y with negative 16.1 t squared plus 50 sine 30 t. Part B says, how many seconds did it take? So I'm looking for time for it to reach the goal. Well, do we know how far away she was? How far away was she? 60. So which one am I going to set that equal to? The x or the y? Which one do I use for how far? X. So you're going to take the first equation, 60 equals 50 cosine 30 t. This is one number. So to solve for t, you just take that 60 and divide. And that answers the question of how many seconds. It's how many seconds that kick is going to take to reach the goal. So I got 1.386 seconds. Anybody else get that? Okay, that's my answer. That's the time it takes for it to reach the goal. Now we want to know at the time it meets the goal. Okay, what was the height? Height. What parameter is height? Y. So we're going to take the t value that we got in part B and substitute that into my y parameter. So y, negative 16.1 t squared plus 50 sine 30 t. I'm substituting in that 1.386. Type that in your calculator. That's going to tell me the height at the post. The vertical height when it reached the post. Or I guess it's not called a post. The goal. The thingy. The net. The goal. It's called the goal. What's the height when it reaches the goal? Type that in your calculator. So I got 3.722 feet. That was my height. I want to know, did she make the goal? Ooh, now I don't know. I think in soccer, we don't want it to go over the net, right? This is my little net. And this little net, this is 5 feet. We want the ball to hit the net, right? We don't want it to go over. So if that's 5 feet, 3.722 is going to hit about there. So the answer is yes, because it's below 5 feet. Same thing, over and over. 2 more. We'll be done. All right, now we're talking about golf. Let's talk about golf. Jim is hitting a golf ball with an initial velocity of 46. Oh, wait a minute. We switched. Meters per second. And the angle is 30. So because it's meters, you're going to use that 9.81. You have to start with negative 0.5 times 9.81. Instead of that 32.2, we got to switch because now we're not in feet. We are in meters. So you got to pay attention to that. What unit are we using? We're using meters. It's either meters or feet. So my parametric equation, x of t, that's just going to be my velocity times the cosine of the angle. Now my y parameter, what do you get when you take negative 0.5 times 9.81? Yep, so we got to start this one with a negative 4.905 t squared plus 46 sine 30 t. And again, we're going to assume that when he hit the ball, it was on the ground. So my initial height is 0. Did they tell us how far away he was from, I don't know, the thing that he was trying to get to? We don't know the horizontal distance, but what we do know is that eventually we want to know how long the ball was in the air. So remember, that's my height. So in other words, when is the height 0? The height is 0 twice. It's 0 when he hits it, and it's 0 when it comes back down. So we're using this equation right here. I want you to set it equal to 0, take out the GCF, and solve it. So 0 equals Negative 4.905 t squared plus 46 sine 30t. My GCF is t. So that gives me two factors. This is factor 1. This is factor 2. So when I set the first factor equal to 0, that represents when he hit it. Okay. Now set the second factor equal to 0. That tells me when it hit the ground. So this is two steps. Subtract that 46 sine 30 and divide by negative 4.905. So I got 4.689 seconds. Anybody else get that? 4.689 seconds. That's how long. So remember, this was t equals 0. And then when does it hit the ground again? At 4.689 seconds. That's my answer. It said, how long was the ball in the air? How long does it take for it to return to the ground? 4.689 seconds. That's my answer to part B. Now, part C asks two things. The first thing it asks me for is the maximum height. Oh, sorry, when. It says when was the ball at its maximum height. And then it says determine the maximum height. Okay, let's look at this motion. What does this motion remind you of? What kind of graph is similar to this?
Quadratic.
A quadratic. In a quadratic, when is it the highest? The middle. Did you say middle? Did somebody say middle? Did I hear that? The middle. So if I want to know what the time was halfway, how am I going to find the time in the middle? What am I going to do with that 4.689? Divided by 2. Wow, look at you guys. I know you can do it. So the highest point is right here, which is halfway through. So at t equals 4.689 divided by 2, that tells me when it was the highest. So the golf ball was at its highest at t equals 2.345 seconds. That's when it was at. This answers the when. Oh. Now it says, well, how high was it at that time? What do you think I'm going to do with that 2.345? Substitute it into y. Let's do that. Thank you. So y equals negative 4.905 t squared plus 46 sine 30 t. And I'm plugging in that 2.345. And that's going to tell me the height at the vertex, which is the middle. What page are we on, guys? 13? We're on page 13, Michelle. But we almost finished with this one. We about to start the next one. So you might as well wait for the next one because, yeah. All right, so the maximum height was 26.962 meters. That's the height. This is the max height. So part C asks for 2 questions. It asks for 2 things. These are my 2 answers to part 2. Last one, we need to know how far it traveled. So in other words, I want to know this distance. This is how far. How am I going to figure out how far it traveled? Substitute, use the x, and what am I going to put in x? Nope. How long did it take for it to hit to the end? Yeah, it took 4.689 for it to hit the ground. So you're substituting in 4.689 into your x parameter. So x equals 46 cosine 30 times 4.689, which is about 186.796 meters. So we got one more question and then we will be done. And you'll have time to work on the last homework of the year, homework 19, guys. One more. Let's look at number 5. Okay, it says, in many U.S. parks, campers must secure food and provision from bears and other animals. One method is to secure the food using a bear bag, which is done by tossing a bag tied to a rope over a tree branch. So suppose the branch is 9 meters above the ground and the person is 6 meters from the branch. That's important. And they throw the bag from 1.5 meters above the ground. This is the first time where the initial height isn't 0. When they threw it, it was already at 1.5 meters. So let's go ahead and figure out. We're going to start by writing our equations. The first time they threw it, they used a velocity of 12 meters with an angle of 60. So let's go ahead and write our equations. X of t equals velocity cosine of the angle t. Vertical parameter, we're using meters again. Half of 9.81 is negative 4.905 t squared plus 12 sine 60 t. And again, this is the first time that we have to add a 1.5. So we need to figure out the time it takes for it to travel to the branch, not the time that it takes to hit the ground. Okay, so I'm not using my y parameter. I want to know the time it takes for it to hit the branch. Do I know how far away the person is standing from the branch? How far away is the person standing? 6. So we're going to use the x equation and set it equal to 6. 6 equals 12 cosine 60, which is one number, times t. So you're going to take 6 and divide it by 12 cosine 60. That's going to give me the time that it takes for it to hit the branch. You should get 1 second. Now I want to know how high it was at that 1 second mark. So if I want to know the height of the bag at 1 second, what am I going to do with that 1 second? Substitute it into what? To y, yeah. So your height is going to be y equals negative 4.905, 1 squared plus 12 sine 60 times 1 plus 1.5. Type that in and let's figure out how high. What's the height of the bear bag? At 1 second. So I got 6.987 meters. Who got that? Now, how high is the branch? 9. And I wanted to go over it. So was that high enough? No. So the answer is no. First time it didn't make it. Didn't make it over. So the person takes the bag and he does it again. This time, he's throwing it at a different force and a different angle. So because he's using a different force and a different angle, we're going to write a new set of equations for part B. So the second time, he used an angle of 45 and a velocity of 14. So x of t. Velocity is 14 cosine 75 t. Your y parameter, go ahead and write it out. So this is actually just like part A. First thing we're going to do, because we know that the person is 6 feet away, I want you to find T. After you find T, substitute that number in for Y to get the height, because the person is still 6 feet away. So I have 6 equals 14 cosine 75 t. And again, this is one number. So t, that's whatever you get when you divide 6 by 14 cosine 75. Type that in to see what you get for t. Lariah, what you get for T? 1.656. Anybody else get that? All right, now let's take that, type it in to our Y. We got to figure out the height. So Y equals negative 4.905 T squared plus 14 sine 75 T plus 1.5. I got 10.443. Oh, it's 75, even 70. All right, so y equals. So the second time he threw it, it was 10.443 meters. Is that high enough to go over the branch? Because the branch is 9 feet. So the answer is yes. It did make it.